Welcome to Ask and Learn.
Okay, so we have to find the expansion for x plus y plus c to the 4. Okay, so the first case is x to the 4, y to the 0, c to the 0. How many ways can we do that? We have to select these 4 elements, x, in this case is x, 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 where the x's are indistinguishable, the y's are indistinguishable, and the z's are indistinguishable. That can be done in one only possibility. Now we have to select 4, and if we select 1 x, let's go with 3x, indistinguishables, 1 y, and 0 z's, that's all the ways that can be done. Let me not add the c because it's 0. Now, we could have, on the other hand, selected instead of the y, the c, and we will obtain that term. Now, suppose that we select 2x instead, 1y, and 1c. So that's x squared, y, z. We also could have selected 2x, 2y's, and no c. So 2x, 2y's, no c. We could have done the same, but instead choosing 2x, no y's, and c's, 2 c's. So we have x squared, z squared. Okay. Now we could have only one x. So that would be 1, and say, for example, 2 for the y and 1 for the z. X, y squared, z. We could have done 1 for the x, 1 for the y, 2 for the z. And that's about all the cases in which x is involved. Now, what if we don't choose x? What if we have only z's and y's? So that would be, we don't choose x. Say we have 4 y's and no z. So that would be y to the 4. We could do the same for z. Let's add another page, keep going over here. Okay, suppose now that we don't have any x, but we have both x, y, and z. So we choose 3 y's and 1 z. We could also have done the other way around. So that would be y c to the 3. Or we could have the same amount of both. Okay, and that's all the cases. So what do we have? we have the case in which all of them are 0 except for the x that appears there, and it also appears similarly for y and z. So let's write x to the 4, y to the 4, and z to the 4. Let's write now the terms that have squares in two of them and the other one doesn't appear. Here, if we look at the number that we have, is 4 factorial over 2 factorial over 2 factorial, and that's actually 6. So we have 6y squared, z squared, 6x squared, y squared, and 6x squared, z squared. And those are all those terms. Now we have the ones that have 3 and 1. And when we simplify, that gives us 4. So that's 4x to the 3 y, 4x to the 3 z, 4x, sorry, no more x. Oh, yes, x, y to the 3, 4x z to the 3, and the one without x, 4x, say without x, y, z to the 3, 4 y to the 3 z. And those are almost all our terms. Now the only thing we are missing is the case in which there is the 3 of them. And only one of them is square that appear here, here, and here. So if we simplify this, that gives us 12. And those terms are then going to be 12x squared y z, 12x y squared z, plus 12x y z squared. And that's the expansion that we were searching